And Nikolai, get our read from her.
In an experiment to investigate the refraction of light through a glass block, a student produced the results shown in Figure 2. Draw the pattern taken by the ray through the block.
All right. So in this diagram, we can see that this ray enters, and what medium is the ray in over here? If you were to say, what is the ray in over here? What medium is this?
Air,
So that's air. Sasha, you're seeing that, right? So outside here is air. This is air over here.
Yeah,
And what do you think is this is? What do you think this is? What?
glass block.
Yeah, this is glass. Now, as you can see, this ray of light is going from air to glass. Which one is more dense, air or glass?
glass.
Right, glass is more dense. Awesome. And air is less dense. Okay, and then we have, so you'll have to draw in the light ray over here, right? You'll have to draw in that. But then it goes back to air. Now, remind me, Nikolai, when you are going from a less dense to a more dense medium, the light, the refracted ray bends what? Do you remember? So if you're going from a less dense to a more dense, what happens to the ray?
Bends away or I think I mixed that up again.
It bends to what?
Towards.
Towards,
Okay.
right? Refracted ray bends towards the what? Towards the what?
The normal.
Yes. And for anybody that's like completely lost, all of these things would have been stuff would have been covered in extreme detail in the past sessions. Everything here we cover like in real detail in like what the last sessions. I promise. I don't have anything here that should be insanely new. All right. And then they are saying part one, draw the path taken by the ray through the block. All right. So Nikolai, it enters at this point and it leaves at this point. So if you want to draw the path taken by the ray through the block, wouldn't you agree it's just this?
Yes, sir.
You're sure, right? Make sense?
Yes, sir.
And you need to draw the arrow. What direction is the light ray traveling in? Sasha, you think I'm gonna draw the arrow in that direction?
No.
Nah. We have to go in the direction of the light ray. So we'll draw the arrow in that direction. Now, Nikolai, back to what we were saying. We were saying if you're going from a less dense to a more dense, the refracted ray will bend toward the normal. Let's see if that's true, right, Nikolai? So, Nikolai, what would I call this line over here? If you had to give it a name, what would you call that?
In the boundary line.
Yes, the boundary line, because that separates air and glass. And the normal would be perpendicular to the boundary line, yeah?
Yes, sir.
Yeah. Let me check something out. So this will be the angular incidence, and this will be the angular what?
Refraction.
Perfect. Now, and I just told you that if you go in from a less dense to a more dense, it would bend towards the normal.
Yes, sir.
And it looks as though the ray it bent towards the normal because this angle is smaller than this angle. I'm not sure if you're seeing that.
Yes, sir. I seen it, sir.
All right, Drew, let me know if you're seeing that. Like it bent towards the normal. Like it bent towards the normal. The angle here is smaller than the angle over here. Drew, you seeing that or not?
Yes, sir.
And that has happened anytime you go in from a less dense to a more dense. It would always bend towards the normal. Okay. So that's the answer for the first question. Danelle, Sasha, Adil, Zachary, Drew. You guys will let me know if you're confused. They wanted us to draw the path by the ray through the block. So the light ray is going to enter the block. It's going to leave the block here, and this is going to be the path taken in the block. All right. I don't hear anybody, so we're going to move on.
Yes, I understand.
All right. Nikolai, anytime you're going from air to another medium, what is the formula for n that you could use? There's a formula for n. Once you're going from air to another medium, you can use this formula. N is equal to what?
Sin I over sin R.
Perfect. N is equal to sin I over sin R. And you can only use this formula when you're going from air to another medium. Now, I'm bringing this up for a very important reason. I suspect that the next question is a graph, and you have sin I on the y-axis, and you have sin R on the x-axis. I'm sure. So, Nikolai, if you have a graph, let me just think about this for a minute, right? And everybody else could answer. If I were to have a graph, and on the y-axis, you have sin I, and on the x-axis, you have sin R, what do you think the gradients would give you? Now, Drew's a maths man. I think Drew could see it. Let me give
Sin I over sin R.
say that again, Nikolai.
Sin I over sin R.
Right, because n the gradient formula is just changing y over changing x. So like you have y over x.
Yes, sir.
Yeah, and so if you find the gradient for sin I versus sin R graph, you're really finding for what?
N.
Exactly. And what does n stand for? Sasha, you know what n stands for? N.
I don't. I can't probably. Yeah, I can't remember.
All right, the refractive index. So the refractive index kind of tells us how much light would bend when it entering another medium. Yeah, that's what the refractive indexes tell us.
Okay.
Quickly think about this, Sasha. Do you think light will travel the same speed everywhere?
No.
Nah. So the denser the material, the denser the medium, it would slow down light more, and so it would bend. And the refractive index N, it kind of tells us, how much it go bend. That's what it really do.
Okay.
Let me observe something. Nikolai, let me observe something, right? So he plotted his results on a graph as shown in page 5. So you see that they plotted sine theta 1 versus sine theta 2. You see now, Nikolai?
Yes, sir.
Now, I have a question. Theta 1, what do you think theta 1 represents?
Sin I, which is A.
Exactly. Anytime you have a diagram, isn't the first angle the angular incidence?
Yes, sir.
Yeah, think about it. This is the boundary line. This is your normal, right? Um, Quickly, this is gonna be your angular incidence, theta I, right? And this is gonna be your angular refraction. And so this is the first angle, and this is the second angle. So, Drew, I really need you to tell me if you're confused. Like, are you confused about why I'm calling the angular incidence the first angle and the angular refraction the second angle?
No, sir.
So you understand the angular incidence is the ray entering, and the angular refraction is the light ray in the medium.
Yes, sir.
So the angular incidence has to be the first angle, and then the angular refraction has to be the second angle. So we effectively have a graph here of sine I versus sine R. Let's look at the other question. Use the graph to complete the table below. So we have a missing table here, and this is 8 Bumbleclot marks. 8 marks, guys. 8 marks. That's a lot of marks, just for filling out that table. That's real easy. So, nah, boy, wait, Nikolai, nah. The spoon feeding out all your boy. Nikolai, what? Read that for me. Calculate the gradient.
End of the graph.
Nah, boy.
This people are coming for CXC.
Nah, boy. That nah. I would never do that. I would be like, calculate the gradient M and say what the gradient represents.
So would you put a mark if you're replacing N with a M? Because I know I lost a mark when they were calculating for something on a graph, and I put M when it was supposed to be another letter.
You had to put your letter. Yeah.
So you would have lost a mark if you put M.
Yeah, you lose a mark.
Okay.
All right. So I'm gonna ask Sasha to help me with the first one. So Sasha gonna help me with that one. Drew gonna help me with the second one. Zachary gonna help me with the third one. Danelle, you gotta help me with the fourth one. This is really easy though. I promise. So Sasha, um, we don't know what the sine theta 1 value is, but we know what the sine theta 2 value is, 0.11.
Mm-hmm.
Now tell me, sine theta 2, does that look like it's on the x-axis or the y-axis? So
The X.
yes, sine theta 2 is on the x-axis. So we need to locate 0.11 there. I have a question, Sasha. We need to come up with a scale. So
Mm-hmm.
how much divisions we have here? How small blocks we have between 0 and 0.1?
And
Yeah, 10, right? So if we want to figure out what one of these small blocks is represent, right, you're gonna say 0.1 all over 10. Now let me explain how that working. Do you understand that from 0 to the 10th block, that giving you 0.1?
mm-hmm.
So if you want to find for one of these small blocks, well, you had to take 0.1 and
I
divide.
divide.
You understand that?
Yeah.
So that will be 0.01. And if you have some trust issues, well, you could count it and check it yourself. This could be 0.01, this could be 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, and what the last one will be?
0.010, but you just remove the zero at the end. So it'll be 0.1.
Exactly. So it will be 0.09, and then you add 0.01 and you get 0.10. Yeah. Cool. Glad you understand that. So every small block is 0.01. So
Mm-hmm.
they give us a value of 0.11. 0.11. So 0.11 would be over here, you agree?
Yeah.
Because we just figured out that every small block is 0.01. So this could be 0.1 plus the 0.01 to give you 0.11. Right. So when you draw a line, you notice that the line at 0.11, it cuts in the graph over here. See that?
Yeah.
So now you're going to take a horizontal read off. All right. Next thing. So Sasha is the same scale. You see, it's the same scale, right? Because, 10 blocks make up 0.1. So it's the
Yep.
exact same scale. So let me try to figure out what this is. You think you could tell me what that one is by chance? The half mark?
Uh, 0.15,
Right, 0.15. So this could be 0.
16.
Right? This look like it's in the middle though. I look like it's in the middle of
Yeah.
0.16 and 0.17. So what would I call that?
Mm, Probably 0.16.
Nah, it's 0.165.
Oh.
Watch. So this could be 0.16 and this could be 0.17. Guys, was in between 0.16 and 0.17.
0.1.
0.005.
0.165. Yeah, right? You guys okay with that? 0.165. How are you feeling about
Mm-hmm.
that? Are you okay with that?
Yes, sir.
All right.
Yes, sir.
All right, so the first one gonna be 0.165. All right. Um, Drew, help me with the other one. So they're telling us the sine theta 2 value. We know that's on the x-axis and they're giving us 0.23. So 0.23 would be over here, you agree? All right, cool. So Drew, I mean, he's a maths boss. This should be obvious, right? If you have a x value, you plug it into the function and you see what gives you the y value. If you have a graph, you just draw a vertical line, see where you cut the graph, take a horizontal read off. That shouldn't be a problem. This should be easy for you. So Drew, read off that value for me. Well, I'm gonna just extend this thing a bit more. Yeah. See if you can read off that for me, Drew.
As what one?
See if you can read off this value for me.
So 0.35 and then 0.345.
Yep. And if anybody is confused by that, understand that this would be 0.35 here, right? And this would be 0.34. And this is in the middle, so 0.345. Okay, Zachary, we have sine theta 1 as 0.50, and we want to figure out the sine theta 2 value. You're gonna have trouble with that, so you think that'll be easy.
That'll be easy.
Okay, so I'm gonna go on the x or y axis.
You're gonna do y-axis.
Gonna go on my y axis, and I'm looking for 0.50, yeah?
Yes, sir.
0.50 is over here. I'm going to draw a horizontal line, and we could see that it cuts in the graph over here at this point over here. So the next step is just to draw a vertical line down. What does that give me? What read off?
So that's 0.33.
0.33. Yeah.
Yes, sir.
Is anybody confused by that?
No, sir.
All right. Because it's 3 small blocks after 0.3. So that'll be 0.03. Yeah, adding on to 0.3. You get 0.33. Cool. All right. Danelle, let me know if you're there.
Yeah, I hear.
So Danelle, in this row, they're giving you the sine theta 2 value.
Yeah,
Remind me, sine theta 2 is on the x or y axis.
the x-axis.
Right. And they're telling us the value is 0.43. So we need to locate
Mhm.
0.43. Remember, each of these small blocks, the smallest block is 0.01. So if this is 0.4, how much blocks I would have to go again to reach 0.43?
3.
3, right?
Mm-hmm.
And so that's gonna be right here. You okay with that?
Yeah.
And just cut in the line,
Oh, yeah. Mm-hmm.
right? So once wherever it cuts the line, you're just gonna take a read off from the graph. So that if I take a read off, that looks like 0.1.
That's 0.65.
Right, because it's in the middle of 0.6 and oh god, we can't escape this 6-7 thing, boy.
Oh,
Wait, I fed up. I'm officially fed up. Nah, boy. Okay, let me just speed around the last ones because I think we get the idea. Just for safekeeping, Danielle, I waited on another one with me. So do 5 for me. So like 5. What value are they giving us?
0.77 on the y-axis.
Right. 0.77, that will be over here, yeah? Just
Yeah.
right.
Mm-hmm.
Right, what value are they looking like?
0.51.
Excellent. Oh, the 8 marks for this, 8, you're not getting 8 marks like this in CSEC maths at all. You had a sweat for 8 marks in C-Sec maths. This is easy, right? 0.87. Let me locate that over here. 0.87 is right here. All right. Yeah. Sasha, see if you can tell me what value that is. This value over here.
Uh, 0.575.
Let me see. So this could be 7. This could be 8. Yeah. Good job. 0.575. Now, when we're finished with everything, I'll explain something. I'll explain something when we're done with all of this. Now we're gonna move on to the last one. All right. So with the last one, 6, 6. I feel like you can't do anything. I feel like they make a mistake there. With number 7. Because you can't really do anything there. Right? My advice though, Nikolai, if they do something stupid like this in the exam, here's what my advice is, right? And you could see that the values are increasing for theta 1 over here.
Yes, sir.
And you see now like 0.16, 0.34, 0.5,
Yes, sir.
etc. Right. My advice is just take a value bigger than 0.87. So like let me pick like a nice one. You know what? Maybe you could pick let me pick like a nice value. I honestly believe they made a mistake, but you know what? Let me just pick a nice value. So Nikolai, this this value I'm picking here, you'll see why I'm picking this. I'm not sure if you can already see why we're picking it, but it's a very safe value. Very safe. Yeah, so Nikolai, you think you could figure out why I picked that value in pink? What
Honestly, no.
said I again?
Honestly, no.
The pink. So let me just write down the values, right? So the values would be that'll be 0.61, and this would be 0.92. Now, the reason why I picked the pink is because it gives us a nice read off. Now, they made a mistake in this question. I'm just saying that out front. They're supposed to give you either one of those. But Nikolai, if something like this happens in the exam, what you are going to do, you're going to pick a nice value. You're going to pick a nice value that is greater than 0.87 and put the read off. So you realize that I picked 0.92 and that gave us a nice read off, 0.61.
Yes, sir. I see it there now.
So like again, you understand that they made a mistake, right? They're supposed to give you one of the values. So you can go on the graph and then read off a value. They made a mistake. My advice is if this happens in the exam, pick a value that is bigger than the last value and then take a read off. That's my advice.
Okay, sir.
Now, guys, you would have noticed that in some of our answers, we have 3 decimal places. But if you look at the structure of the table, what is the highest degree of accuracy? Tell me, guys, when you look at the table, what's the highest degree of accuracy?
2.
2. So we would actually have to write our answers correct to 2 decimal places. So let's quickly do that. So 0.165 will be rounded off to what? Could anybody tell me?
0.17.
Right? Sasha, 0.345 will round off to what?
0.35.
Yeah. Hmm. 0.575 would round off to what?
0.58.
Right. So this is my piece of advice. If you have a table and everything in the table is the two decimal places, make sure whatever you put in is also the two decimal places. That's my advice. And everybody in class, could all of us agree that all of these are points on the graph? Yes or no? If you don't understand what I mean by that, tell me. But like, if you understand, let me know.
Yes, I understand, sir.
Zachary, do you understand that all of these values here are just points on the graph?
Yes, sir.
And if you don't believe me, let me just verify that one more time, right? So like, what about 0.11, 0.17, right? 0.11, 0.17. Yeah. Let me know if you're okay with that. Okay, maybe I should do a more obvious one. What about like 0.65, 0.43? Right, watch. 0.43, 0.65. You seeing that? So do you understand that all of those pairs of values are just points on the graph? Yes or no? Zachary, I'm not hearing you. Let me know if you understand that or not. Okay, I'm not hearing Zachary. Drew, do you understand that all of these pairs of values are points on the graph?
Yes, sir.
Okay, cool.
Say it, no?
Yeah, I hear you now.
Yes, sir. My mic was giving a little trouble, but I understand, sir.
So if I ask you guys to find ingredients, is that something you'd be able to do?
Yes, sir.
Okay, good. And my advice is remind me. So Sasha, sine theta one, was that the x-axis or the y-axis?
The y-axis.
And sine theta two was the
X-axis.
great. Right. Now, Nikolai, read part three for me.
State two necessary precautions that the student should have taken in conducting the experiment.
Right. And what exactly was the experiment?
Um, Refraction of light passing through the glass block.
Right. Did you do this lab in school as yet?
The experiment or the question?
The experiment.
Nah, I
Nah,
don't think no. We did one with the prism and the colors. That's the only thing I remember that we did for experiment. The next, we did a lab like this, but not the experiment.
I see. Well, you see these, I want to explain something, right? Unless you like these alarm dots over here. Unless you know little dots. Yes
Yes,
or no?
sir.
So for anybody that would have done this lab in real life, what you actually do is you shine a laser and you would take these pins and you would put the pins, like two pins, so you could kind of like trace the path of the ray. Understand?
Yes, sir.
So like you'd have a light ray over here and you'd stick two pins here so you could like get a rough estimate of the line. And when the laser beam comes out, you'll stick two pins here to be able to draw the light the light ray when you take off the laser. That makes sense?
Yes, sir.
Okay, good. Sasha, you ever do this lab in
Yeah, I did this lab before.
with the pins and whatnot, right?
Yeah, even though I like when I do the lab, I didn't understand one thing about it at first, and I wasn't getting through the refractive on the other side. And I was like, tell us about that. And he was like, yeah, you go find it. So I just, mirror somebody else one. But I did get through the lab in the end then.
You get through with it or you didn't get through?
I get through with it in the end then.
Okay, cool. So guys, Nikolai, if you are using a glass block, and obviously you would want to make sure it clean first.
Yes, sir.
Yeah. So like number one, inspect glass block for any cracks or marks. Right? If dirty, clean block. Do you guys understand that if something is dirty, it could possibly affect the way in which light travels?
Yes, sir.
Okay, cool. Could you guys think of a second precaution?
Depends.
Right. Depends. I have a question. If you want to, if your goal is to draw a line when the laser is off, do you want to place the pins really close together or like far apart?
Far apart.
What do you guys think? Close together or far apart?
But
Exactly, because if you have them far apart and you put on your ruler, you can get a nice line. If you put a point here and you put a point here, bro, what are you doing? What are you doing? All right. So the second thing that you should do is place the pins far apart. Place the pins about like 5 centimeters apart.
Wait, so
Yeah, Drew?
you can explain what the pincers do again?
Okay, no problem. All right, so Drew, how this is work, right? Is that you have a, let me see if I could draw this for you quickly. So you'd have a piece of paper here, right? Following, you have a piece of paper, and you have a styrofoam block underneath the paper. You with me?
Yeah.
All right, cool. So you have a styrofoam block, and you have a piece of paper here. Next thing, you're gonna have your Perspex glass block over here. Yeah,
Mm-hmm.
you're gonna have a laser, and you're gonna take the laser and you're gonna fire it into the glass block. And let me just draw the arrow to signify the direction. Now that is going to bend upon entry, and your final ray should exit like so. So this is generally, this is what would happen. Could you visualize it?
Yes, sir.
All right. Now, is the light rays gonna remain there? If you take off the laser, are the light rays gonna remain there?
No.
No, they're not gonna remain there. So you'd want to like, wait, sorry about that. Massacre. Uh, uh, all right. Yeah, guys. So, Drew, as I was saying, when you take off the laser, the light ray is gonna vanish. Yeah, it's gonna vanish. So to lock the path, to like lock the path, to remember what the path was, what you're gonna do is you're gonna stick pins. So I can stick a pin here, I could stick a pin here, and I could stick a pin here. Understand?
Okay.
And so when you take off the laser, remember this paper underneath is styrofoam. So when you
Mm-hmm.
stick the pin gonna remain there, pin gonna remain there, pin gonna remain there. When you're ready and you finish with the experiment, you take off the pins and you'll have small holes in the paper. You can then take a ruler and line it up and draw a line. and that would simulate the path of the light ray. Understand?
Also, it's just a mark where the light went, how it passed.
That is all. And it's the same thing on the other side. You put a pin here, you put a pin here, you put your pins, and when you take off the laser, you'll have these holes to guide you as to how to create the line, the light ray.
All right.
And think about it, Drew. If you want to accurately draw a line, would you want to place the pins very close together or like kind of far apart?
Kind of apart.
Exactly, right? Yeah,
That's just tough.
no problem. So do you understand why one of my precautions was place the pins far apart?
Yes, sir.
All right, cool. All right, calculate the gradient n of the graph. Now we know that the gradient formula is what? Sasha, what is the gradient formula?
Sine I over sine R.
Okay, what you're saying isn't wrong, but that's not the gradient formula. The
Oh,
gradient formula is really change in y over change in x. So that will be y2 minus y1 all over
oh,
x2 minus.
over X.
But we
Okay.
understand that this would represent, it represents sine theta 1 all over sine theta 2. That's what it represents, which is n. But they're just asking us for the gradient for now. So let me stick to that. So in finding the gradient, you could actually use any 2 points from this table. You can use any 2 points from the table. Next question. Are you all going to use the ones that we rounded off, or are you going to use the ones that gave us nice results? What would you use? The ones we kind of had to estimate, or the ones that gave us nice results? What would you use?
The nice results.
Yeah, the nice results. So my advice, I would advise you to probably use this one, this one, this one. All of those are fair game. So I'm gonna use these two over here. So Nikolai, if I write this as a point, what would that point look like? What would this point look like?
0.03 and 0.05.
Wait, you mean 0.33?
Yeah, my bad, 0.33 and 0.50.
Right, and we could call that x1, y1. All right, Sasha, tell me the other point.
Um, 0.43 and 0.65.
Right.
By the way, so what past paper is this?
This is either January or June 2014. Yeah, can't tell you the specific months, but 2014. Right, and Sasha, if we call in this x1 and this y1, we think we call this on this.
X2, Y2.
Yeah. Bro, I don't want to zoom in. I want to copy this. Hey, copy this, right? And I want to put it over here. Paste. So let me go. And Nikolai, we're not gonna write M, eh? We're gonna write N. So we're gonna say N is equal to what? You know what? Let me ask Amira. Amira, we find an gradient. And I already have 2 points there. Tell me what to write, Amira. By the way, good evening, Amira. Good to have you here. Okay, Amira not here, and Amira. Okay, I see she on mute. Nice.
Me?
Yeah, Amira talking to you. Tell me what you write.
I'm s- So I don't know.
No, you know this is not hard, but watch. We find an ingredient. We already picked 2 points for the ingredient. You just had to tell me the values. You just had to substitute.
Oh, 0.65 minus 0.50 over 0.43 minus 0.33.
So Amira, I hope you understand that you shouldn't just say like, nah, boy, I can't do this. This was very, in fact, something that's very simple. So I don't want to say that I just can't do this and give up. Don't do that. Right?
Okay, so
All right. So Amira or anybody in class, plug this into your calculator and let me know what you get. What you guys getting? You should get like a nice answer. A beautiful answer.
I get 1.5.
Anybody else getting 1.5? Guys, come on, lock in. Let me know what's going on. I'm not hearing anybody. What's going on here? Sasha,
I don't know.
hope you have a calculator there.
Um,
yes, so the answer is 1.5.
Right.
I calculate, you like,
Say that again.
I said I had the calculator, but I know the calculator, you like it.
Even if it's not the calculator, like you should still get it correct. If all you have a sharp, you would need to put this into your calculator. So you'd have to put for all the sharp
Yes.
users, you'd have to plug this in. You would say 0.65 minus 0.50. You'd put that in brackets. Then you'd press divided, open bracket, 0.43 minus 0.33.
I had the calculator on my phone though, so not to worry.
All right. Well, yeah, you're supposed to get 1.5. And guys, all they should know what that 1.5 means one time. One time. All they shouldn't have to question it. Because when we was doing this topic, right? Well, we do for air, we do for water. Did I do glass? Did I do glass? Did I think we did that past paper on that? I'm not sure. Okay, well, we didn't do glass, so I could give a little lie. But Nikolai, and we did do the refractive index for water.
Yes.
Right, and the refractive index for water was like 1.43, and
Didn't I just saw a moment just 1.3 or something?
yeah. Now, I have a question. What do you think denser? What I'm asking everybody this, right? What do you think denser, water or glass?
Glass?
Or what the rest of people in glass? Earlier, think about it. What denser, glass or water?
Glass?
Yeah, glass. So which one would have a higher refractive index? Remember, refractive index tells us the degree of refraction. The more dense something is, the more it is refract. So tell me, guys, do you think water is gonna have if you're comparing water and glass, which one would have a higher refractive index?
Glass.
Glass, sir.
Glass, because glass is more dense. And we see in that we get 1.5. The refractive index for water is 1.43 or 1.3, depending. Sometimes it'll be a bit different. But I hope all you see making the connection between density and refractive index. the greater the density, the higher the refractive index. Yeah. Are you understand that?
Yes, sir.
Yes, sir.
Yes, sir.
Now they're asking us part B. What physical quantity does the gradient represent?
So I honestly want to know this one, sir.
It just refractive index. But refractive index are what?
Of the glass, sir.
Pass?
Yep.
That is what it means, sir?
Yeah, I believe so. That's the only answer. That's the only feasible answer I could think. That's what it represents, the refractive index. But it said physical quantity. Let me just verify that. Yeah, it is a physical quantity. That is what they want. That's the only thing it could be. Think about it, Nikolai. That's the only thing it could be, right? Because the gradient is literally sin I over sin R, which gives you the refractive index. Yeah, you understand?
Yes, sir. I was doing the 2026 physics paper two now, sir. And I saw this question came up again. And I
Ah,
didn't know what to put in because it was the insulation of the two test tubes.
I will check that paper just now. But the
Yes, sir.
answer for this is just simply the refractive index of what?
Of the glass.
Yeah, of glass. Not just any glass, of the glass block. Right, Sasha, you understand now, you're confused.
Don't understand.
All right, and if anybody is confused, I'm going to put a little graph here so you'll be unconfused. That's a word. I don't think that's a word, but I'm going to call it a word regardless. So over here, we had sine theta 1, and we should know that sine theta 1 is the same thing as sine I. And what do they have on this axis? I'm not hearing anybody, but they had sine theta,
Sine R or
right?
sine theta.
Just sine R. Now everybody should be able to see that this is the y-axis and this is the x-axis. Now, whenever you are finding gradients, you are finding the change in y all over the change in x. That's what you're really finding. And so when you find the gradient, look at what's on the y-axis. Sine I, sine theta 1. So you are really finding sine I all over what? What's on the x-axis?
Sine R.
Yeah, that's what you find, and you find in sine I over sine R, which we know to be n, which is the refractive index.
Okay, sir.
Index of. All right, so I hope we understand that. All right, I hope we okay with that. Anybody confused about the answer for part B? If you're confused, talk to me. Let me know if you're confused. Danelle, Amira, Adil, Drew.
Well, now I understand
Yes, sir.
because
I
I
understand.
didn't understand what they mean by physical quantity. I thought they was talking about like the SI unit or something like that.
Now they want to know like what does this represent? Like what does this mean? What does the gradient represent? Like
Okay.
a similar type of question they like to ask. Let me show you, right? So you should know Ohm's law is equal to V is equal to IR. Yeah?
Yes, sir.
Right. So if you plot a graph of V versus R, then the gradient would be, remember, Y over X. So the gradient would be V over R. And what do you think V over R would give you?
We'll give you a high.
Yeah, it would give you I. So they might give you a graph of V versus R, and they might be like, find the gradient, and then it would be like, state the physical quantity it represents. and that will be current. You understand?
Yes, sir.
So all of these questions has to do with the formula associated with the concept. So like this formula is Snell's law. All right. I'm gonna call upon Zachary to help me with part C. So Zachary, read part C for me.
The Patsy says it is known that the gradient is related to the speed of light c1 in air and the speed of light c2 in the glass such that n equals c1 dash c2.
All right. And they're telling us C1 is equal to 3 by 10 to the power 8. Find the value of C2. Now, guys, just to make sure that we're all on the same page, they're telling us it is known that the gradient is related to the speed of light C1 in air and the speed of light C2 in the glass, such that the refractive index is equal to C1 over C2. And before you say, so I never see that in my life, I don't know what the heck I'm talking about. I'm going to show you that we did cover that. We did. We did. I promise we did. Let me look for the formula real quick. Watch. Watch this. I gave you guys all the formulas for refractive index. Zachary, what's the first formula right on there?
N is equal to the speed of light in the air over the speed of light in the medium.
Right. And what symbol do we typically use to represent speed of light? Do you know?
Yeah.
Yeah, we use C. So this will be C1 and this will be C2. So that's why you're seeing N is equal to C1 over C2. And didn't I tell you guys that refractive index just is like, it's kind of tell you, like give you a degree as to how much light gonna bend. And doesn't light bend the most in in like a denser medium? Like depending on the density of the medium, light would refract more. All you understand this, right?
Yes, sir.
So all these are formulas for refractive index. We are just comparing how the light is behaving in air to in the medium. That's what we do. So Zachary, I hope you understand that that's not scary. You saw it before. All right. So Zachary, in this question, they want us to find the value of C2. Yeah?
Yes, sir.
First things first, Zachary. Did they give us any formula we could use in the question?
No, sir.
I see a formula, and I just show you a formula, which is the same formula here. There is a formula in the question they gave you.
Yes, sir. I got it already.
Zachary, I promise it right there. The formula right there.
So we'll speed of light over the refractive index.
Nah. Call out the formula for me. Call out the formula for me that you're seeing.
And is
Oh,
it
N is
Wait.
equal to C1
Yeah,
slash
yeah.
C2.
Yes. Sasha, you were seeing that formula in the question?
Yeah.
All right. Before we move on, right? Let me just write down that formula in big. They gave us that formula. N is equal to C1 all over C2. They gave us that formula. What else did they give us? Could anybody in class tell me what else they gave us?
the
What?
speed of light was C1?
Okay, so they gave us C1. We know that C1 is equal to 3 by 10 to the power 8 meters per second. And you should know that's just the speed of light in air, right? That's the speed of light in air. Now, I wonder, I really, really wonder, what else do we have in this question? What else do we have? Nikolai, stay quiet. Nikolai, want to answer. Rest of people in class. We have C1. What else do you think we have?
So we have N.
Exactly. Could anybody tell me what N is other than Zachary? What did we find N to be?
The gradient.
What we find N to be? What was the value for N?
1.5.
Exactly. So you should be like, oh, okay, if you forget what, okay, right there. So the thing is, we have N and we have C1. That means we could form an equation with how much unknowns? What would be the only unknown there?
C2.
Exactly. C2 would be the only unknown. So let me do some substitution. So I know that n is 1.5. I know that C1 is 3 by 10 to the power 8. And I do not know what C2 is, so I'm going to put over C2. I'm going to leave that blank. All right. This might be looking a bit complicated, so what you could do is you could cross multiply. Guys, I could write 1.5 as 1.5 over what? Come on, Zachary.
Over one, sir.
Over 1. And I could cross multiply. If I cross multiply Zachary, what am I going to end up with?
One point five by C2 is equal to 3 by 10 to the power 8.
All right. And how am I going to find for C2?
You divide by 1.5 on both sides.
Right. So do you understand that density medium, the slower light go travel?
Yes, sir.
And I think you could see it there because notice we dividing the speed of light by what?
The refractive index.
Exactly. So the denser something is, the bigger the refractive index will be. And as a result, it will cause light to travel slower. Because imagine if the refractive index was 7. And you just slow down light by 7 times.
Yes, sir.
Right. So I hope you're seeing the connection there. So what is 3 by 10 to the power 8 all over 1.5?
I got a very big number, sir.
Yeah, you get a very big number. Tell me your answer in standard form.
Anybody could answer.
Yeah, anybody could answer.
I get 2.0 times 10 to the power 8.
What you get?
I get, is either, is either 2.0
Yes,
times
sir.
10 to
The
the
answer
power
you say was
8,
correct.
or it could be point 0.2, nah, 2.0.
Yeah, it's just 2 by 10 to the power 8. And if all you're utterly confused, watch this, right? I could rewrite that as just 3 over 1.5 by 10 to the power 8. Now, Alia, how much times 1.5 go into 3?
2 times, sir.
2
Right.
times,
So it's really just 2 by 10 to the power 8. That's it. And you need to put your units, otherwise you're not gonna get full marks. Was the units for speed, Sasha? Was the units for speed? Speed.
Is it? I think it's V equals U.
Nah, the units for speed.
Mm, is it V?
Nah. So the units for speed is meters per second. And let
Mhm.
me show you an easy way to remember that. So what's the formula for speed? All right, Sasha, even simpler. When you're driving and you look at how fast you're going, what do units is be?
Kilometers.
Just kilometers?
Uh, kilometers per hour.
Kilometers per hour, because it's telling you how much kilometers you go travel in an hour. Now in physics, what is the SI unit for distance? What do we measure distance in physics?
meters.
Right, meters. And Sasha, in physics, we don't use hours, we just use what? What's the SI unit for time?
Students use seconds.
Right. So meters per second. Yeah. So think I'm sure you never think about that, right? Like wait, just think about a simple example. Speed is kilometers per hour, but in physics, the unit speed is used as meters and seconds or meters per second. Speed. Yeah. And if you ever forget the formula for speed, well, Sasha, you can use that same thing. Like you just figured out, it's kilometers per hour, right? Kilometers per hour. What does kilometer measure?
Distance over
Right.
time.
Exactly. So if you ever forget the formula, you could derive that. You could figure that out in the exam. Right. Easy 3 marks. So guys, did we understand this question? Let me know, guys. Did we cook?
Yes, sir.
Nice. What about the rest of you all?
Yes, sir.
Let's sure. Amira, if you're confused, talk to me. Let me know what happening.
I understand.
You sure?
Yes, sir, I think so.
Okay. Adele, Drew, Danelle, how we feeling? How we feeling? Danelle, you understood everything we did?
Yes, sir, I understand everything.
All right, blessings. So we done with Snell's law. Let's go. All right. Also throw back to Bruce and the bad breath. Yeah. And he covered. No, no, I was going to say this is cavities, but this is grills. That is Bruce Grills. You know what I mean? Bruce real harmony. So I don't know why he had a chase down poor Nemo. All right. So let's move on. Y'all are probably excited to move on. I am too. So let's look at lenses. So we are going to look at lenses. Now there are two types of lenses. Does anybody know the types?
Convex.
Wavelengths and divergent lens.
All right, so I heard somebody say convex lenses, right? Yeah, so you have a convex lens. Denel, you say convex?
I said convex.
You said convent?
No, I said convex.
Oh, Sasha,
It's
I can ask why you say convent.
no,
Convent. What? When you look through a convent lens, does that mean you're gonna talk like a convent person? Oh, Nicola,
can't come. And I
Nicola,
can't come
you know about the
Sir,
convent accent? Anybody know about the convent accent or
across.
is that a joke? Is
Trust.
that a joke? Is that a joke? Anybody here from convent? The only girls we have here is really Karina. Karina, I think you're from convent, are you not? Can I hear in Karina? But anyways, convex lens, another name for convex lens is convergent. Okay, what's the other type of lens called?
concave or divergent.
Yeah, concave lens. Cool. And so let me quickly draw a convex lens for you guys. This is what a convex lens typically looks like. Wait. Okay, that's a convex lens. It's kind of a bad diagram, to be honest. Give me a moment. It's a fat convex lens. Okay. All right, and you're probably wondering why we're calling it a convergent lens. Let me show you why. So imagine you have some light rays entering here, right? Imagine you have some light rays. They are entering, right? Now, when you guys hear the word convergent, what comes to mind?
Comes closer, I'll count to 1 point or something.
Yes. So guys, when the light ray passes through the lens, well, we could see that this lens is going to pass through the optical center. By the way, we call this the optical center. Light rays that pass through the optical center are unimpeded and they just continue going. So there'd be no change there. So let me just give you all some names one time. This is the optical center. That's what we call the optical center. That light ray is just going to pass straight through that. All right. Okay. What did you all notice? Could anybody tell me an observation that you could make from this diagram?
They're all passing through at the same direction.
Say that again.
They're all going at one direction.
Um, I suppose so, yeah. So like all the light rays,
Say they coming together at one point.
exactly. All of them, that's the main thing I want you all to see. We have these lines here parallel to the principal axis. You'll see what the principal axis is just now. Just now. All of these lines are parallel. Number one. When they pass through the lens, all of them are convergent to a point. The next thing I want you to realize is that the light ray passing through the center just goes straight through. But the main thing you should see is that they converge at a point. And everybody can see that they converge at a point.
That's it.
Right. That point is called the focal point. That's the focal point. Understand? Let me know
Yes,
if
sir.
right. Okay. Cool. Let us look at a concave lens now. Is there anybody that didn't understand the concept of a convex lens? Ollie, I don't like the silence, like we will fall off for the silence like that. I
Hey,
can't.
could you repeat?
Yeah, you okay? You understand the concept of the convex lens?
Yes, sir.
Yes, sir.
So this is what concave lenses look like. It's mager, it's skinny, it don't eat enough food. The convex lens take all the food. If you know somebody like that, you should probably message them right now and be like, stop eating all my food. Yeah, until they really see that the convex lens kind of fat and the concave lens kind of skinny.
Yes, sir.
Yeah, I see in that. All right, so I'm going to repeat the same process. This center over here, can somebody tell me what would I call this? What's the name? What's the name of this again? The center of the lens?
Optical center.
Yeah, it is. That's called the optical center. Now, this one is a bit harder to catch, but I still think y'all could figure it out. Now, any light ray that passes straight through, that passes through the optical center, it goes straight through. So could you guys see that the light ray is just going to go straight through because it passed through the optical center? It's just going straight through.
Yes, sir.
Okay.
Yes, sir.
All right. Now, Sasha, when you hear the word divergent, you think of coming together or moving apart?
Comment together.
Nah. diverge.
Oh, moving up. Sorry.
Right. Let me just put this in simpler terms. Because like for me, it sound like something common, but I don't think it's necessarily uncommon. Because like how much of you guys hear the word conversion often? Are you ever hear that word before? If you do in geography, you probably hear about like convergent tectonic plates or like divergent something. I didn't
Yes,
do geography in a long time. But when you hear of conversion, I want you to think of coming together.
Yes, sir.
Right? So Sasha, now you know. And well, divergent means to move apart. Move apart. They're moving apart. Move apart. Cool. So what if we have another light ray over here? It is going to move apart. It's going to move away. If we have one over here, I have a question, guys. I want you guys to tell me if you think this is correct or if this is wrong. Do you think that would be wrong or correct?
Wrong, sir.
How about the rest of you guys? Are you think that would be correct or wrong?
No.
That would be wrong.
That'll be wrong, right? Because it looked like it converging. It come into this, it approaching that one, but we know that is not the case, right? The rays are gonna move apart. So after it exits the lens, is actually going to move apart like this. Right. So with lenses, a couple things are very important: the optical center and the focal point. Now, did everybody understand why I call this the focal point? Because it was the point at which all the light rays come together. So that was important. That was very important. Did you guys understand that? The focal point for a convergent lens is the point where all of the light rays come together. We understand now or no?
Yes, sir.
Okay. We all we need to figure out the focal point for a divergent lens now. So how do you think we do that? This one is a bit harder to digest. It's a bit harder. So Nikolai, obviously you can't put your focal point wouldn't be over there, right? Because these never touch. Like these
Yes.
lights never touch. So let me show you guys how you'd figure that out. If you have a divergent lens and you want to figure out your focal point, this is what you would do. You're gonna take a ruler, you're gonna line it up with one of the rays after, right? And well, yeah, there you go. Yeah, so this one is a bit harder to understand, but for that divergent lens, this would be your focal point. Yeah, I know it's a bit weird to understand, right? So for a convergent lens, the focal point is after the lens. It's in front of the lens. And for a divergent lens, the focal point is behind the lens. Right. Do you all understand the general gist of these two lenses? If you really don't understand, talk to me now and I'll re-explain it. Okay,
Yes, sir.
Danelle, talk to me, Danelle. Let me know if like things real bad. Let me know if things real bad.
No, sir, I understand everything so far.
You're sure, like 100%.
Um, yes, yeah.
All right. So guys, we're gonna do a quick trivia now. Somebody tell me fast, what kind of lens this is?
Convex.
You all agree? All right. What's the other name for this lens? Other than convex. Wait, what would you call it?
Converging.
Converging, yes, yes. What would you call this? That's the
The
what of
optical center.
right. If I have a light ray and it passing through the optical center, would it bend or would it go straight through?
Straight through still.
It would go straight through. Good. What do I call this point where the light rays converge to?
Focal point,
Like
sir.
point still.
Right, that's the focal point. And quickly, Danelle, what was the name of this lens again?
Repeat, sir.
This
Yeah, Danelle.
this is a convex lens.
Right. Is a convex lens also called a convergent lens because the light rays would converge that point after the lens. Right. Cool. Next one. What's the name of this lens?
Diverging lens.
Concave.
Right? Concave or divergent. No, guys, what's the name of this point here? In the middle of the lens.
Optical center.
Right. If I have a light ray passing through the optical center, will it bend after or will it go straight through?
Straight through.
Yes. Anytime you have a light ray passing through the optical center, it goes straight through. Straight through. Right? And that is what creates the principal axis, as you will see just now, I promise. Right. Sasha, tell me if this is correct or this is wrong. For a divergent lens, is that correct or is that wrong?
Wrong.
That's wrong. It's supposed to look like that, yeah?
Yeah.
All right. What about, is that correct or wrong?
Wrong. It's supposed to be going downwards.
Probably saying this man can't teach physics now. He'd be showing me the wrong thing. Oh, all right, yes. Supposed to go downwards. And if I wanted to find a focal point for this lens, how am I going to do that?
Before the lens. So where the lens diverging and going into a point before it enters the optical center.
Right. So to do that, you're going to take a ruler, you're going to line it up with one of your rays, and you're going to extend it backwards. And that would give you your focal point. All you feel like, all you okay with lenses so far?
Yes, sir.
Well, that is extravagant news. So let's specialize now. Which lens do you want to look at first? The convex lens or the concave lens?
Concave.
How about the rest of you guys? Concave or convex first?
Yes, a concave.
Okay, no problem. Concave here. So as you know, this is our concave lens, is a divergent lens. Yeah, we know that. And so let me introduce you to some rules. Let's look at some common rules you should be acquainted with. Rules. Number one. A ray of light right? A ray of light passing through the optical center right? Passing through the optical center of a lens go straight through Okay, I need you to tell me if you're utterly confused by that first rule. Let me know if you're utterly confused by that first rule. Is anybody in class utterly confused by the first rule?
Nah, so
Yes, sir.
Can you see what I mean by this diagram?
The line at the center.
Exactly, the line at the center, it passing straight through the optical center. So you know, I just keep going. Just go straight through, straight through. Now, let me just label this thing quickly. So O, that is my optical center. And remind me, what does F stand for again?
Focal point.
Right. And that refers to the point by which all of the light rays converge to or diverge from. Right? Focal point. Right. So that's the first rule. So let me show you guys what a ray diagram is now. So the ray diagram looks similar to this, but I'll show you using an example. So let me give you all an example of what I'm talking about here. So when you are drawing your ray diagram, you would have your principal axis. This is your principal axis. I tell you now, the lenses is one of the easiest topics, like for sure. It is just look hard in school, but like it's so simple. Could somebody quickly tell me what this point could be called? What is the name of that point? Tell me fast.
Optical center.
Right, that's the optical center. And do you understand that? Let me know,
Yes,
guys.
sir.
Yeah, we understand that. That is the optical center. All right. Let's just say that this is F. This is 2F. All right. This is F. This is 2F. It's only looking complicated, but stay with me, right, guys? Stay with me. Okay. Let's just soak the scene. So, Nikolai, can you see that we have a line passing straight through the optical center and it just keep going?
Yes, sir.
We call that the principal axis. That's the principal axis. Now, all length is taken with reference to the optical center and any distance along the principal axis. So let me explain what I mean. So we have a principal axis over here and we have the optical center. If you wanted to take a measurement of length, you would measure from the optical center to that point on the principal axis. So that's something you have to be acquainted with. So if you want to measure length anywhere over here, you're going to measure it along the principal axis. So, Danelle, let me know if this very confusing, if you kind of understand what I'm talking about here. So I put on a divergent lens. I put on a divergent lens. I have a line here passing through the center called the principal axis. The point in the middle, I call it the optical center. And I have some focal points over here. Let me know if you understand that.
Yes, I understand.
All right. And now, do you think all lenses would have the same focal point?
So far.
Or do you think all lenses would have the same focal length?
Um, no.
No, because
Or it's
and
yeah, okay.
think about cameras. And cameras, if you ever use like an actual DSLR, it have a bunch of different lenses you could use. Like lenses to zoom in, lenses to zoom out. I mean not zoom out, but like lenses for like wide to capture like wide point of views. The point is, different lenses have different.
Mm-hmm.
So in other words, Janelle, different lenses would cause the light to focus a certain distance away from the optical center. Maybe you might have one lens that causing the light to focus at this point, and maybe you might have another lens that causes it to focus at this point. You know what I mean? Different lenses do different things.
Okay.
So we have the principal axis, we have our divergent lens, and we have the focal point. So let me give you an example of what I'm talking about when I say a ray of light passing through the optical center of a lens goes straight through without being refracted. Let me show you. All right. So Danelle, if you're confused, just tell me, right? That line that I just drew,
Okay.
where does it pass through?
This is the focal length.
Wait, is that purple line I just drew?
No, wait, sorry. What is that? Like the focal, the optical
Optical,
center?
yeah, this is the optical center. Let me put a little label by it quickly. Optical center. So what do you guys notice about that purple line? That purple ray of light? What do you guys notice about it? Did it
It
refract?
passes through the center.
It passed through the optical center, but did it bend, did it refract, or did it just go straight through?
Straight through, sir.
Right. Karina, Zachary, Danelle, Sasha, Adil, Amira. Guys. Yeah, yeah, Barry. Exactly. Yeah. Um, let me know if you understand the first rule. So, like I'm saying, if you have a line and it passing through the optical center, it's just gonna go straight through. Are you understand that or not?
Yes, sir.
Yes, sir.
Okay, so tell me if this
Yes,
is
sir.
would that be correct?
No,
Can anybody tell me why that would not be correct?
Not
because
passing through
it's
the
not
center.
passing through the optical center.
Exactly, not passing through the optical center. What about this? Would that be correct?
Yeah.
Yeah, because the light ray would go straight through. If it passes through the optical center, it's gonna go straight through. Amira, Adil, Drew, Nikolai, Zachary, Danelle, are they understand that, Sasha? Like once the line passing through the center, it'll go straight through. It wouldn't diverge or converge or anything. It's just gonna go straight through. Let me know if they understand that.
Yes, sir.
Are they sure?
Oh, yeah.
Yes,
Yes,
sir.
sir.
All right, let's move on to the second rule. Right. A ray of light, which is parallel to the principal axis, after refraction, appears to be coming So let me try to explain the second rule for you guys. Now you would ask, this second rule is not alien to any of you guys. As a matter of fact, I would have demonstrated it over here. Somebody read the second rule for me. Somebody read the second rule for me.
The ray of light which is parallel to the principal axis after refraction appears to be coming from the focal point.
Right. So let me just try to give you an example of what I'm talking about. So we're gonna draw a ray diagram. By the way, you see what I'm drawing here? This is called a ray diagram. So I want you all to tell me if the line I'm drawing is parallel to the principal axis. Would that line be parallel to the principal axis, which is the black line?
No, sir.
Or what do you all think? Sasha, would that purple line be parallel to the principal axis, which is this line? Okay, do you guys know what parallel means? If you don't, that's fine, just tell me.
Yeah, it could be
Uh,
parallel.
Sasha, you say yeah, it will be parallel?
I mean,
Actually, you wouldn't. But let me show you why. So when we say parallel, we're talking about two lines that would never meet. They would never meet. Those are parallel lines. But if you look at this, if I were to extend this line, eventually it's going to meet the black line. They are not parallel. Parallel lines are lines that never touch each other. So let me just correct that quickly. What about now? Would that line be parallel to the principal axis?
yes, sir.
Yes. No, guys, what did I say here? I'm saying a ray of light which is parallel to the principal axis. We just draw that. It says after refraction, so after it passes through the lens, it appears to be coming from the focal point. So let me show you what I mean by that. So I'm going to put on a ruler here, and I'm going to align my ruler with the focal point. Okay. I don't know if you guys understood that. So let's apply it to the rule again. So the rule says a ray of light, which is parallel to the principal axis, we have that over here. It's parallel to the principal axis. After refraction, so after it passes through the lens, it appears to be coming from the focal point. Guys, this is the ray after it passes through the lens. Doesn't it look like it is coming from the focal point?
Repeat, yes.
Nikolai, how much are they here?
I have 9.
Yeah, I'll explain the whole thing. So, if you have a ray of light, which is parallel to the principal axis, so we drew that, this purple line here is parallel to the principal axis. After refraction, so after it passes through the lens, it is going to appear as if it's coming from the focal point. Can you see that that line appears to be coming from this point?
Yes, sir.
Yeah, we could see that. So that's what I'm talking about. Wait, give me a second. Uh, Yeah, I feel like all don't understand this at all. That is what I feel.
So I have a
Talk to me.
question.
Yeah, then I'll talk to me.
My question was, how do you know at what you hear me?
You're breaking up.
Hello.
Yeah, I hear you. Talk to me.
Oh, you hear me now?
Yeah.
I was wondering at what distance do you know you're supposed to draw the focal points on the axis? Is it in that the refractor is?
Or they would tell you. They would specify any question.
I don't.
They would tell you any question. So like they would tell you that the lens has a focal length. They might say the length has a focal length of 5 centimeters. So from your optical center, you go how to go 5 centimeters, and that will be your focal point. And 2f just means 2 times the focal length. So that'll be like 10.
Okay.
Mhm. Yeah, again, I really feel like I don't understand this. So I feel like we need to look at another example. I could tell when people are very confused. All right, so Sasha, and I'm going to put on the rule here. I'm going to put on the rule again, and we're going to understand this. All right, so Sasha, give the rule a read for me.
Area of light which is parallel to the principal axis after reflection appear
Refraction,
to be
refraction.
refraction, sorry, appears to be coming from the focal point.
All right, so Sasha, the first thing they say an array of light which is parallel to the principal axis. So I'm going to draw a ray of light that is parallel to the principal axis. That's the first thing I'm going to do. Does that look parallel to the principal axis?
Yeah.
You sure?
Yep.
Anybody confused by that first part? A ray of light, which is parallel to the principal axis. Is anybody here confused by that part? Danelle, Zachary, Nikolai, Karina,
No, sir.
Adele, Amira. So like, watch, if you're confused, this line is a ray of light. This line is the principal axis. These lines will never ever touch, so they are parallel. Hope you understand the first part. Then we go on to say after refraction. So Sasha, after refraction is when the light ray passes through the what?
Focal point.
After it passes through the lens. Now, I have a question, guys. Do you all think that this would be correct? No, remember, this is a divergent lens, right? Do you think that this would be correct?
No.
No, sir.
No. So my question is, how am I going to figure out how to draw that line? I can't just draw it, I can't just draw that. It needs to be tied back to the focal point. And again, appears to be coming from the focal point. So here what? Can anybody tell me how I would be able to draw this line? How am I going to draw this line here?
Diversion going outwards, but it had to reach, or when you're drawing the line to the focal point, it had to be straight.
Okay, so like, wait, Tama. So like, could I just draw? I want everybody to talk to me, right? Would this be correct?
No.
No, sir.
Just because Karina and Nikolai say no, that don't mean you want to say no, right? Only say no if you're sure you think is no. Amira, Adil, Drew, Zachary, do you think that's correct or no?
Yes, sir.
Zachary, you think that correct?
I think so.
All right. So Zachary, that brings me to the next thing. If I were to extend our line behind the lens, does it look like it's coming from the focal point itself? So it's over here. Does it look like it's coming from the focal point itself? Is this point over here the focal point?
Nah, so
All right. But your rule says after refraction, what? After refraction,
appears to be coming from the focal point. So that line wrong. So
right? Sasha, Amira, Danelle, if I were to extend this line backwards, does it look like it's coming from the focal point itself?
No.
If you're confused, right? The focal point is over here, but this is going over here. Is it coming from the focal point? Danelle, is it coming from the focal point?
No.
No. If I want it to come from the focal point, I need to take my ruler and align it with the focal point, like so. And I'm going to draw my line. Who here is confused by that? Is there anybody that's utterly confused by this? It ain't no shame in saying you're confused, you know. But it would be shameful if you get the question in the exam and you get it wrong. That would be shameful. But like, now is the time to ask questions. Is this utterly confusing?
No, sir.
If you don't understand it, tell me now, you know.
No.
Amira,
No.
Adil, Drew, are they understand how I was able to draw my real light after it passed through the lens?
Yes, sir.
So what did I do? I took my ruler and I lined it up with this point here and this on the focal point, and then I drew my line. One thing to keep in mind though, the line you draw on behind the lens is a dashed line, a light dashed line. Once it passes through the lens, you draw a solid line because that's the real light you'll see when it exits the lens. That's where you'll actually see. Okay. I'm not sure if I truly understand that. I'm really not sure, but if you genuinely understand it, give me like a sign. But only say you understand it if you actually understand it. Eh?
yes, I understand.
Okay, well, if you understand, I can give you a question then, and you should be able to get the question correct. That's what I think. Sasha, if you're confused, talk to me, you know. Tell me if you're confused by anything at all.
No, I understand it, I promise.
So you had to line up the ruler, eh? You can't just willy-nilly draw a line. No. You have to line it up with the focal point. Remember, it had to be appearing as if it coming from the focal point. So it had to be coming from the focal point. Right. And don't forget your arrow too, eh? To indicate the direction of the light ray. Okay, let me just give me a moment. So let me just take a screenshot of this one too. So I can see how I did it. Okay, so let me actually do a question, all right? Um, and you all are gonna draw this in a book. Question. A concave lens has a focal length of 4 centimeters. As such, complete the ray diagram to illustrate the light ray after right. So a concave lens has a focal length of 4 centimeter. As such, complete the ray diagram to illustrate the light ray after refraction. So, guys, what do I call this black line over here? Could somebody remind me? What's the name?
Principal axis.
All right, that's the principal axis. I'm going to draw my lens now. What would I call this red point in the middle? What's the name of that point in the middle? Does anybody remember?
Optical center, sir.
Right, that's O. Sasha, remember that point in the center of the lens, that's the optical center, right?
Yeah.
Now, if I have a light ray passing through the optical center, does it get refracted? Yes or no?
No, sir.
No, it doesn't. It just goes straight through. Remember that, guys? That's why that Nikolai, can you understand that that is how I have a principal axis? That's the only reason I have a principal axis, you know. Because the principal axis is just a light ray that goes straight through the lens. That's the principal axis.
Yes, sir.
Okay, now guys, in the question, they said that the concave lens has a focal length of what?
4 centimeters.
4 centimeters.
Okay, if that is the case, how am I going to figure out where to draw my focal point? Can anybody give me some instructions?
From the optical center, go 4 centimeters backwards.
Yes. Okay, is anybody utterly confused about that?
No, sir.
Okay, sure.
Yes, sir.
All right, Danelle, he was asking me how would I know where to put F? So in the question, I told you that we have a focal length of 4 centimeters. So what did I do? I drew my lens, I put on my optical center, and from the optical center, I measured 4 centimeters and I put F. That represents the focal point. Let me know if you understand that, Danelle.
Yes, sir, understand.
All right. So I am going to draw a light ray here. And I want you to now draw the light ray after the lens. So that's what I wanted to do for my complete this diagram. So it don't have to be anything too specific, right? The main things you need to check, okay, the main things you need to have, you need to make sure that the focal point is 4 centimeters from the optical center. You need to have that. After you do that, just draw a line parallel to the principal axis, go into the lens, and just I want you to draw how it would look like after it passed through the lens. And if you need any help, um, you can take a screenshot of this quickly. Take a screenshot of this quickly if you need to. I give you another chance to take a screenshot of this if you need to. Five, four, three, two, 1, 0. Okay, back to the question. I give you another 3 minutes.
So are we done send it, yeah?
Yeah, send it to me.
So we're not doing 2F as well? Or it's just F?
I don't have enough space to put on 2S.
Okay. So I just draw my concave lens kind of smaller, so
All
not
right.
that but same thing that also.
Oh, you know who Drewski is?
Yes, sir.
Oh, you see the new skit?
Yes.
I do not know who is that, sir.
Yeah.
The one with oh, he looked like Erica Cook. Yeah. I hear the man getting soon now. It's crazy. Nikolai, send it to me.
Yes, sir, but it's still loaded for some reason.
Okay.
So I'm gonna try it again.
All right.
Yes, sir, this one's sending now, so you can check it then.
All right, let me see where you draw it. One thing you forget though, you forget your arrows. You need to put your arrows. But other than that, that's fine. That looks correct.
Oh, okay.
Yeah, so that's good. Right? Rest of you all, I'm waiting. I'm waiting. It's easier than you think. It's very easy. All right, so Zachary, don't forget to draw your little dashed line like this. Look
Ah,
like,
yes, sir. I forget to draw that.
yeah, that looks correct.
We so for the Ray had a touch that last line.
Yep.
All right, so
Okay. Danelle, Sasha, Karina, Adil, Drew. I'm waiting, guys. I'm waiting. I'm waiting.
Yeah, I can send it to you in a little while. My internet giving trouble.
Our class had to finish just now because
I'll
it's
send it to you. I'll send it.
all right. Okay, I'm not hearing all there.
Hold on, I'm sending it too.
All right.
Wait, so we supposed to be doing something?
Yes. Are they supposed to be are they supposed to fill out finish that diagram? You was
What? And just draw the array after refraction
yeah, you're supposed to draw the ray after it passes through the lens.
and the dotted line to the focal point.
Yeah. Yeah.
So what? Send it to you. Send a picture.
Yes, on a picture.
Oh,
All right, guys, so we're gonna correct this. All right, so Amira, you there? Okay, it would appear Amira is not here. All right, Danelle, let me run through this together, all right, Danelle? So to answer this question, uh, tell me, Danelle, can you just, well, you know it's a divergent lens, so you know it's gonna diverge outwards, it's gonna move apart. Can you just draw a line like that, just so? Tell me, Danelle, can you just draw a line like that?
No,
No, you can't do that, right? You need to take a,
no.
and you need to line it up with the focal point, like so. Let me know if you catch that.
Yeah.
Right, Sasha, it kind of look like you ratchet that, eh? You're supposed to use an actual ruler. Yeah. If you're freehand in
I
the
think
exam,
you something now.
if you're freehand in the exam, they're just gonna get a big fat zero. They're not gonna get you full marks. Even though it look correct, they're not gonna get you full marks. So I just letting you know. Make sure, well,
Yeah.
obviously you go have your pencil case in the actual exam, but yeah. All right. So that's the answer you're looking for. Did everybody understand that?
Yes, sir.
yes,
Okay.
sir.
Now, before we leave class, let's look at a couple cases of diagrams. Now, anytime you're doing an actual ray diagram, you have to incorporate rule 1 and rule 2 to look for a point of intersection to obtain the height of your image. That sounded scary, but it's actually very simple. There we go. I'm gonna finish class in 40 minutes. Yeah. So let's go. So we have a couple cases, right? These are the cases. Number one, your object is beyond 2f. That's one case. The second case, your object is between f and 2f. Third case. Oh, none. For this, these are the only two cases you really have to concern yourself with. If the object is beyond 2f and if the object is between f and 2f. And I'll show you why. Right? Now, something to keep in mind here, once we're dealing with diverging lenses, this is gonna happen. So asterisk here. Note. So for concave lenses, no matter right, so no matter where you place the object, you'll always get an image with the following properties. Are they probably confused? Like, where this man pull out object and image from? What? It'll be fine with the following properties. So the first property, your image will always be virtual and upright. Virtual and upright. Number two, it will be diminished. Probably saying, what? Virtual? What? No, real confused. Help me there, help me there. All right. So virtual, a virtual image is just simply the image formed behind it forming behind the lens. So a virtual image is an image formed so anytime you see the word virtual, please note that virtual means behind the lens. That's what it means. So virtual just means it forming behind the lens. Behind the lens. Behind the lens. Well, are we okay with that?
Yes, sir.
Okay. And the word diminished just means smaller. It just simply means that the object height, the image height will be less than the object height. Okay, maybe you might still be confused about what is the object and what is the image. Well, the object, okay, I have a question, right, guys? If I put on, like, okay, if we in real life and you take a picture of, say, a dog, well, I wouldn't call a dog an object. Let me just say you take a picture of a charger, right? You have a charger on the table and you take a picture of the charger. Aren't you using a lens and a camera to take a picture of
Yes, sir.
right? After you take a picture of the charger and you look at it on your phone, what do you call that?
Virtual image of the charger.
Yeah, you call that image, right? Janelle, that makes sense. If you have something in real life, you have an object, and you take a picture of an object and you get an image.
Yes, sir.
Right. So, guys, if you're confused, the object is the actual thing in real life. So you have something, you take a picture. When you're looking at the picture of the object, you call that the image. So understand the object is the actual thing. The image is what's formed when you look through the lens. Hope we understand that. So let we go. Let me look at case one. All right. I really hope you all are not lost. I would definitely say this is one of the easier topics if you're following along. If you're lost right now, you're only gonna get more lost. So the first case we are going to look at is the object is beyond 2F. Okay, I'm gonna start from scratch. So does everybody understand that this is called a ray diagram? This is a ray diagram, and we have a
Yes, sir.
divergent lens. Danelle,
Yes,
Sasha,
sir.
Zachary, Drew, we have a lens here, right? A divergent lens to be specific. Yeah?
Yes, sir.
Although I have more people than Nikolai in class. Are they okay with this? Are they familiar with this diagram?
Yes, sir.
All right, here what we're gonna do. In this case, they're saying that we're gonna have an object beyond 2 times the focal length. All right. So I'm going to just put down an object over here. Wait, could everybody see that I have an object over there?
Yes, sir.
Okay. And I place the object beyond 2 times the focal length. So could you all see that that is 2 times the focal length? This point over here.
Yes, sir.
Right. And Sasha, did I place it at 2F or past 2F?
Past 2F.
Right. So we have an object here. Now wouldn't the object have a height?
Yeah.
Yes, the object would have a height. Good to know that. So the object is going to have a height. So with that information, so imagine like the sun hit this object. If the sun hits this object, it's going to reflect light, and a light ray is going to come from the object and it's going to enter the lens. And so from the object, we could actually draw a ray of light. And a ray of light is going to enter the lens. Do we understand that so far? So like, imagine you have an object here. Once we have light, this object is going to emit light rays. Isn't that how we see things? We see things because there's light.
Yes, sir.
Right. So we have a light ray, and the light ray is going to enter the lens. Now, we already know how what's going to happen, right, Danelle? It's going to diverge. And we know that the light ray is going to diverge.
Yes.
Yes, it's going to diverge. And so to draw that, you're going to take a ruler and line it up with the focal point, like so. Let me know if you understand that. Anything new or something you're familiar with?
Yes, I understand.
Okay, happy to hear that. What about the rest of you guys? Do you all understand?
Yes, sir.
Okay. The
Now,
next,
what's one question? Wait, one question, right? When you
yeah,
say the object is beyond 2F, does that mean the direction of where the ray pointing would have hit 2F or it hit F alone?
no, it will always hit F. F is the focal point. Remember, F is the point where the light rays would converge to or they would diverge from. So Nikolai, the whole point at 2F is just to say that it's that this point over here is 2 times the distance of the focal length. So like if the focal length here was 5, then this point over here would be 10 and we would call it 2F. But light itself converges or diverges from the focal point. The focal point is like that very important property of our lens. 2F
Okay,
is just
so
a reference point. If I wanted, I gotta have 3F, I gotta have 4F, etc., etc. Right? But the main thing here is F. If you look at all the prior diagrams that I did, what do you notice?
it always hitting the F.
Right, so Zachary, watch. If I were to draw an object here, wouldn't that object be beyond 2F? Watch, look for yourself, Nikolai. What would have created this light ray? Well, an object over here. So if I put on an object over there, you can see that, watch. Is it anything alien or like you see it before?
I see it before.
Right. Okay, so I hope everybody understands what I did so far. So we just applied the second rule. Let's apply the first rule now. If I have a light ray passing straight through the optical center, what will happen?
It just keep going straight.
Exactly. So the next thing we're going to do is we're going to draw a light ray from the object passing straight through the optical center. And what exactly are we looking for? We are looking for a point of intersection. Are you guys seeing a point of intersection?
Yes. Actually, two.
No,
Oh,
only one. We're looking for a
yeah,
point
because
of
I
we're looking for a point of intersection between the purple line and the green line. Are you all seeing an
ah,
intersection?
yes, sir.
Right. Is it after the lens or is it before the lens?
Before.
Right. Then now, Sasha, are you seeing any intersection between the purple and the green after it passed the lens? So the purple going in that direction, the green going in that direction. Are they like intersecting? Are they like crossing each other?
No.
Yes, sir.
Wait, are they seeing them crossing each other? When I say crossing, I mean like they crossing each other. Are they seeing them crossing each other after
Oh,
it?
they're not crossing.
Nah, they just diverging. But if we look before the lens, are you seeing any like it cutting, crossing, seeing anything? If you ask me, yes, there is. Watch. I don't know if all seeing that, but look, it's there. Are they seeing what I'm talking about?
Yes, sir.
Yeah, I feel like all so confused. If you're confused, please tell me. I will try every effort to explain it back. Wait, let me find a good color. All right. Could everybody see that behind the lens, you have an intersection over here, the crossing over here? Danelle, Sasha, Zachary, Drew, are you seeing that? Yes or no?
Yes, sir.
Yes, sir.
Right.
Yes, sir.
So let me explain what happened. You see this blue box over there? That, my friends, is the object. This is the object's height. So I hope we understand that. Now, as you can see, that is my image. That is my image. That is going to be the height of my image. So when you're drawing these diagrams, this is what the diagrams typically look like. So you would have, this way you would have, right? So if I lose one, you just tell me. So when you're doing these diagrams, you would have an object height. So that arrow over there would represent the height of the object. This intersection, I need like a really, really small line here. Let me see. Yeah. Could everybody see this small arrow over here? Yes or no?
Yes, sir.
All right, Danelle, Sasha, Zachary, Drew, are you seeing this small arrow over here?
Yes, sir.
Yes, sir.
Right. So
Yeah.
that would represent the image. Question, was the image bigger or smaller than the object?
Smaller.
Danelle, if you're looking at the height of
No.
the image, if you're looking at the height of the image, which one is bigger, the image or the object?
The object.
Object. So, do you understand why I said earlier that for a concave lens, no matter where you place the object, you'll always get an image that is virtual and upright and diminished? So let me try to
Mhm.
understand that. First of all, this image, is it forming behind the lens or after the lens? Where's the image forming?
Behind the lens.
Right. So it's a virtual image. Check. Is it upright?
Yes.
Yes, it's upright. Check. Diminish just means the image height will be less than the object height. Is it smaller?
Mhm. Yes.
Yes. Great. So let me just run through this procedure one more time for anybody that might be utterly confused and they don't want to say you're utterly confused. The first thing you want to do, you want to draw your ray diagram. You're going to put on your principal axis and you're going to draw your lens. Next thing you want to do is you want to put on the focal length or put on the focal point based on the focal length. Then you can put on your 2F, which is just 2 times the focal length. And I would place an object over here. Everybody understand that the object would have a height? Yes or no? Do we understand that the object would have a height?
Yes, sir.
Right. So you need to apply the 2 rules you learned to find a point of intersection. So the first rule you learned was that if you have a light ray passing through the optical center, it's going to go right through. Isn't that what we learned? And we learned that, right? If you have a line passing through the optical center, it will just go straight through.
Yes, sir.
So I have the
Yes,
green line over there. And then the other thing you'd have learned, if you have a light ray parallel to the principal axis, it is going to appear as if it's coming from the focal point. Now, utilizing these 2 rules, by using these 2 rules, I was able to get an intersection behind the lens. Are you seeing the intersection behind the lens?
Yes, sir.
Right. And that would tell you the image height. So you can see that the image height is less than the object's height. You can also see it is behind the lens. So I would say that the image is virtual and upright, and I would say it's diminished. Danelle, talk to me.
Yes, I just wanted to find out if the image was on the other side, would it still be considered upright?
First of all, it could never be like it can never be on this side. But like, let me give you an example with a convergent lens, right? This is like a insight into the next class. Watch this, right? Um, This is for a convergent lens. Notice where the intersection is. See that? The intersection is over here.
Mm.
That would
Yeah.
that would be considered laterally inverted. It's like upside down. Yeah.
Right.
But like for a concave lens, you could only have upright images. You could only have upright. Yeah.
Oh, okay.
Here what? Before we end class, let's do another one quickly. So what if the object is between F and 2F? Let me do this thing quickly. It's extremely simple. You just have to spam the two rules and you're looking out for a point of intersection. That point of intersection will tell you where your image is and the height of the image. All right. Zachary, you there?
Yes, sir.
All right, Zachary, let me speed run this thing, right? So Zachary, in this rounds, I'm going to place my object where? Where am I going to place my
Between
object?
F and 2F.
You're right. So tell me where I should stop, right? Should I stop here?
Nah, sir.
How about like here?
Yes, sir.
All right. Could everybody in class see that I've placed my object between F and 2F?
Yes, sir.
All right. So which rule do I want to apply first? The parallel or the straight through?
The parallel.
Okay. So Zachary, I'm going to draw a parallel line to the principal axis. Let me know if you're confused by that.
Nah, sir.
You're sure you understand that?
Yep.
And for me to draw the diversion ray, I'm going to take my ruler and I'm going to align it like so. You follow it?
Yes, sir. Yes, sir.
Going to draw a dashed line over here. I'm going to draw a solid line over here.
Yeah.
Everybody in class understand what I just did? Or they're confused?
Yes, sir. We understand, sir.
All right, where's the next rule I have to apply?
The straight line passing through the optical center.
Right, so you're going to see me drawing a straight line through the optical center like so. Anybody confused?
No, sir.
Danelle, let me know if you're confused.
No, sir.
All right, so Danelle, where did the image form?
Behind the lens.
Right, and if I were to highlight it to be over there, right? See that?
Mm-hmm.
So again, it's virtual. It is diminished because it's smaller and it's upright. So it's diminished, upright, virtual.
Yes, sir.
Is there anybody utterly confused by the ray diagrams and how to figure out where images and image heights?
No, sir.
Nah, sir.
Okay, cool. If you could understand this, then the next class should be cake because we'll be looking at convergent lenses. All right. Um, is there anybody confused in class? Before we call it a night?
No, sir.
Here what? For homework, you all could try and see what happens if you place the object different places. So that's what you can do for homework. You can mess around. So for homework, let me just give all you some homework quickly.
excuse.
Yeah.
Um, this time from 4 to 6 could be a regular thing, or you're going back to 10 to 12.
I mean, I don't mind doing it 4 to 6,
Oh, oh.
I just need to find out from the rest of them in the chats. Yeah.
All right, no problem.
Right. But F. So here what? This is what I could do for homework. So Nikolai, you could draw 3 diagrams and you could place the object at 2F. You could place it at F. You could place it before F and see what happens now. But the same thing should happen. The same thing should happen. You should have a virtual and it should be upright. It should be diminished.
Okay, sir.
Yeah, so this is all the homework. So all you find like everything today was like understandable?
Yes, sir.
Okay, good.
Yes, sir.
Well, I'll have a blessed night. Take care, guys. Later.
All right, sir. Same to you as well. And hope you feel better soon as well, sir.
I hope so too, eh? This headache don't want to leave. I'll make sure and take all the vitamins and thing, eh? Nope.
Yes, sir.
Panadol, I'm taking Panadol, I know, but still that is headache. This headache I want to leave.
Sir, you should try Panadol Rapid.
Guys, you only green, like little green on its ends?
I think so. Yeah, yeah.
Because as take that, it's worked to some extent, but I wish it would have worked better. I wish it would have worked better. Yeah.
Oh, okay, sir.
Well, yeah, guys, I hope all you have a blessed night. Later.